Hi everyone, it's Mrs. Slauson, and so we're going to be working in our packets, and we're going to be working on page 11 in that packet. So you'll want to get that out, but this is kind of like a little pre-video to watch, and so I'm going to ask that you just watch it because it's going to do a lot of explaining of things for our next video. So in this upcoming chapter, we are working on graphing, and so in our notes that we did, excuse me, I'm grabbing them, in our last video I talked about the three different forms of a quadratic. And so there's standard form, which tells you the y-intercept. There was vertex form, which tells you the vertex. And then factored form, which tells you the x-intercept. So these are notes that you already have. And so what we're going to look at today is how do you go from standard form to vertex form. So before we do that, I need to talk about a certain type of trinomial that happened in our last chapter that we could factor, and it has a special name. It's called a perfect square trinomial, and I'm going to explain that to you now. So if we go back to the way we were factoring in chapter 8, which we had for showcase of learning number 4, on all these problems I'd be making an x, right, because they all have 3 terms. And normally what I would do is I would first look to see if there's a GCF in these problems. So I'm going to go ahead and tell you that none of these have a GCF. So I'm just going to work on making the x. So I'm going to multiply these. So I need factors of 16 that get to 8. In this one, I want factors of 100 that get to 20. For this one, I want factors of 16 that get to 8. And for this one, I want factors of 4 that get me to 4. So that's just a quick refresher on how you make the x. So now what I'm looking for is what are those factors? So what factors of 16 are going to give me 8? Well, that would be a 4 and a 4. When I look for factors of 100 that make 20, well, that would be 10 and 10. So just a reminder, when I multiply these, I get the 100x squared on top, and when I add these, I get the 20x on the bottom. So factors of 16 that get me to 8 would be 4 and 4. And factors of 4 that get me 4 would be 2 and 2. So the first thing I want you to notice is that all the numbers that I wrote in black, all those side numbers are the same. And that's really important that in what we're doing here, that those side numbers are going to be the same. Okay? So what I can do now is make those parentheses, and I'm going to go ahead and fill out that x, just like we did in chapter 8. And up here. Okay? So now I'm ready to start the factoring. So I already have the x and the x for the x squared. So now I need the numbers for 16. So I'm going to switch to a pencil here if I can find one. So you got to give me a moment. I look for one. I think I have one, and then I don't. So let's see. So the factors of 16, what numbers can make 16? I could choose between 1 and 16, 2 and 8, or 4 and 4. And so I need to be picky because only one set of those numbers is going to get me to 4 and 4. So first of all, 1 can get me 4, but 16 can't get me 4, so that's out. 2 can get me 4, but 8 can't get me 4, so that's one's out. So I'll be using the 4 and 4. So the 4x and the 4x are now going to make that 16x squared. And then I can make my head. And these are both the same. So it really doesn't matter which one I start with. And if you notice, those are both the same. So as it turns out, when I follow these loops, I'm doing the same thing twice. So 4 times what can make that 4x? Well, that's a positive 1. And then 4x times what can make that 4x? That's a positive 1. So let's go to this one. Here I'm looking for the factors that can give me 25 because the x and the x are already the x squared. So will it be 1 and 25 or will it be 5 and 5? Well, here it's going to be not 1 and 25 because 1 can get me the 10, but 25 can't get me the 10. So it's going to be 5 and 5. And hopefully you're starting to realize some things here, that these numbers are the same. Just like those numbers were the same, right? A lot of things are the same here. And so now I can make the face to get these side numbers. And so 5 times what can get me 10? Well, that's a positive 2. And 5 times what can make this? That's another positive 2. So hopefully you're starting to notice that these are the same. So now when I'm trying to figure out what times what is going to give me 4, because the x and the x make the x squared, 1 and 4 or 2 and 2, we will be picking the same numbers. And now, making the face, 2 times a positive 1 can make this, and 2 times another positive 1 can make this. And then the same thing would happen here. So we already have the x squared from x and x, so if I make the face, to get these side numbers, it's going to be an x times a positive 4 to make this 4x, and an x times another positive 4 to make that 4x. So what we're going to start to realize is that instead of writing something twice, you can write it once with those parentheses squared. So I can write this as 5x plus 2, parentheses squared, 2x plus 1 with those parentheses squared, and x plus 4 with those parentheses squared. Because the exponent, that little 2 that's hanging out there now, tells me how many times I'm multiplying those parentheses. Okay? So that's the first big thing. So that was just, you could sit back and watch that. You didn't have to necessarily write all that down. And now we're going to start to look at this process called completing the square. So this is not some tools that you have at home. So you just kind of got to watch what I have. Normally these are labeled. And so let's see if I have a marker that would label these. I don't think I do, though. I'm not seeing one. Just pause for 1 minute. All right, so I've labeled them. I found a permanent marker, but let me describe what these are. These are called algebra tiles, and we're going to take a look at how you go from standard form to factored form. So this piece is called x squared because we're going to look at this. I'm writing on a whiteboard right now. Is this having a dimension of x and this having a dimension of x? And then if I want the whole thing like this, that's the area, and I would just take the length times the width, the base times the height, and x times x is this x squared. So this one, this whole length is this x right here, but then there's just this one little piece, so this is a 1. So to find the area of this side, I would take 1 times x, and that's why this whole thing is called x. But this little length is 1, and this full length is x, and what you see written on there is the area. And then this little square, well, this is just a 1 by 1 square, and so if I find the area of 1 times 1, I get 1. I hope that makes sense, but that's where that's all coming from. All right, so first what we're going to do is I'm going to show you how we can take something and turn it into something like this, a perfect set of parentheses squared. So what I'm going to do is I'm going to take x squared, and we'll just start with 6x, and we're going to be finding out what number goes here to make this a perfect square trinomial, so that when we're done factoring it, right, that we have 2 identical sets of parentheses that we can then just write as one set of parentheses squared. So the question is, what is that number going to be? So this is how that works. Here's x squared, and then I'm going to take 6 of these. They're not all going to be labeled, though. Okay. And what I need to do is figure out how many of these little pieces am I going to need right there. So what I'm going to do is take my 6 x's, and right now I'm trying to make a square out of them. So right now what I have is a rectangle. So what I'm going to do is separate them out a little bit. And I'm going to take these 6, and I'm always going to take these individual like long rectangles and cut them in half. So I'm going to cut this in half, and I'm going to put 3 of them horizontally this way and the other 3 vertical this way. So hopefully you can start to see that square building up. But what I need now is a lot of these to fit in there. And how many would it take to fit in there? And it's hard to turn. And so I make a perfect square. So my question is, how many of these do I need? And hopefully you can see that by now because it's taking a long time to do. But I need, imagine, I need 9 of them, okay? So that's the number that's going to be going here. And now if I ask you to find factors of 9 that get you to 6, That would be 3 and 3. And then I could make my two x's for my parentheses, and then x times positive 3 makes one of those 3 x's, and x times the other, another 3, makes this other 3x. And then instead of writing it twice, I can write it once squared. Okay? So let me show you another one. All right, so this time we're going to do x squared plus 10x. I don't know if I have 10 of these, maybe. And what number would have to go here? So here's my x squared, and I need 10 of these. So there's 6, there's 7, 8, 9, 10. So right now, if I just put them all together, I have a rectangle, and I'm going to start to make a square. So there's the x squared a little separated. And so what I'm going to do is just before, I'm going to take these 10 and split them in half. I'm going to divide them up into 2 parts. And so 5 of them are going to go this way, and 5 will go this way. And what I would want to know is how many of these little squares would it take to fit in here. And so hopefully you can see that I actually don't need to put them all in there, but there's this empty space that I need to fill in. So a little tough to do. And I can see that I need 5 of these little squares here. So 1, 2, 3, 4, 5, and 5 more this way. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And if you just keep that up, because I don't have enough little squares, you'll actually end up with 25 of those little squares. And so if I do take the time to factor this now, here's my x, I need factors of 25 that get me to 10. Again, you're going to end up with those identical numbers here. And then when you make your parentheses, the x and the x here make this x squared. And then x times what will make this 5x? Well, that would be 5. And then x times what will make this 5x? That would be 5. And then writing them, instead of writing them twice, we can write them once squared. Whoops, sorry, you can't see that. So let me show you how that looks here. So going back to this, I'm going to do a little erasing up here because I need the space, is, remember, I showed you this earlier, that this side length is x, and then each little edge here is worth 1, and I've got 5 of them, so there's x plus these 5 more. And then here, this side is x plus 5 of those little spots. That's supposed to be an x. And then when you're trying to find the area of a square, you take the length times the width, the base times the height, and that would be my length and width, which I could write like that. So I hope that all makes sense. But that is the first part to completing the square. And what a perfect trinomial, perfect square trinomial looks like. Okay, so again, going back to this yellow page, these were all called perfect square trinomials, and that's going to become really important once we get to completing the square. So let's take a look at some problems that we're going to be doing with standard form going to factored form. So we're going to start out with this problem. Okay. Sorry, I'm just coming up with the numbers. All right, so what we're going to do is here's my x squared. Here's my 4 x's. And then here are 1, 2, 3, 4, 5, 6, 7, 8, 9. So what we're going to do first is we don't need these 9 little pieces right now. So I'm just going to kind of set them off to the side. And I'm only going to worry about these x's. And I'm going to do the same thing I did before. So let me flip this over. So I want to take this, right? And I'm going to do what I did before. I'm going to take these 4. I'm just going to split them up. So 2 will go down here, and 2 will go down here. So I still have x squared plus 4x. It's starting to build that perfect square. And now I'm going to take these 9 pieces, move this down a little bit, and I'm going to fill in as many of these as I can right in here. So I can fit 4 of them in there. Right? And so if I start to look at this and label these sides of this perfect square, remember this side is just worth x plus 2 more here. And then this side is worth x plus 2 more here. And so now, instead of writing x plus 2 times x plus 2, I can describe this big square here as x plus 2 squared. But, whoops, you can't see that. But I want you to notice that I actually have more than that. I actually have 5 more pieces, 5 more of these little squares. So in addition, and each square is worth 1. And what I've done now with these squares is I've gone from standard form to vertex form. And from our last section, you got to remember that each one tells you something important. So going back to those notes, standard form tells me the y-intercept. X is always 0, and I want the constant, the term that has no x with it. So that would be, in this case, 9. So I can see a y-intercept. And then what we did is we found its equivalent form in vertex form. And vertex form tells you the vertex. You want the opposite of h. H is in the parentheses. So when I look in the parentheses, I see 2, but I want the opposite of that, so I'll take -2. And then I want my k value, but I want that k value. I don't want the opposite. So that's the number that's added or subtracted at the end. And since it's added at the end, I'll use +5. And then I see the vertex of the shape. So I can start to go from one form to another. All right, so let's try another one, and then I'm going to stop this video, and I'm going to, well, maybe 2 more, and then I'm going to show you, we're going to work on the notes. So again, you're just sitting back watching. It is pretty important to watch this, though. So let's try x squared plus 6x, and let's try 12. I hope I have 12 of these. All right, so again, here's my x squared. Here are my 6 x's. And then I'm going to have 12 of these little pieces. So there's 4, there's 7, 8, 9, 10, 11, 12. All right, there's the 12. So first I'm going to assemble my square. So these 12 are just going to go off to the side for now. And there's the 6, and just like before, they're making a rectangle, so I'm going to break that 6 in half and move half of them here, and the other half here. And so what I'm going to do now is fill in the square by taking as many of these 12 little ones that will fit in here, and that will take 9 of them. So there's 3 of them, 3 of them, and 3 of them. All right, so I still have 3 left over. So now this square can be described as x on this side, right, plus 3 more. And this, sorry you couldn't see that, can be described as x here plus those 3 more. So when I look at the area of the square, it's x plus 3 times x plus 3, which we're going to write as x plus 3 squared. So that's the whole squared, but I actually have a little more. I have 3 more of these little squares, and each little square, if you remember, is worth 1. So plus 3. So again, what we did is we just went from standard form, and I can see its y-intercept, it's 0, 12, to vertex form, and I can see its vertex, so I take the opposite of this number, and this one I don't take the opposite. All right, so last one, a little different, and then we're going to take a look at our notes. So in this one, we'll just do something small, like x squared plus 4x plus 1. So here's my x squared, here are my 4 x's, and then there's the 1. So just like last time, the 1's just going to go off to the side. You can kind of see it in the top right of your screen, and I'm going to take these 4, and I'm going to cut it in half. And then I need to build my squares. So what's happening is I only have 1 to fit in here. So now when I describe my square, this is x plus those 2, and this x plus these 2. So if I wrote the area, I'll do it as x plus 2 squared. So this is the full square, but it's not a full square. It's actually missing something. So it's lost something. 3 of these little squares And so since it's 3 of them, I'll put 3. So again, we just went from standard form to vertex form. I can see the vertex of -2, -3. I can see the y-intercept, 0, 1. All right? So now what we're going to do is we're going to put this all together in the next video of the notes. And so this is a longer video for today, but watching this will definitely help make things more clear when we go to the notes.